So let's look at differentiating trig functions, the 6th section in the differentiation chapter. Now you are given these, these two here you need to know. So sine, we need to know differentiated becomes cos, and cos, cosec, cos becomes negative sine when we differentiate it. So these you need to know. The other trig identities will be given in the formula book, so need to memorize these. The other ones I'm going to give you over here, these are in the formula book, so in the formula booklet. Right, so let's go through them. So what are we missing? Sine, cos, right, tan. So if y equals tan x, then dy dx is equal to sec squared x. What are we missing as well? All the reciprocal functions, so that's sec x differentiated. This is a strange one because it's got two bits to it. It becomes sec x tan x. Then we've got cosec. Now actually, one way of remembering this, although you don't need to remember it, because here if you put plus co in front here, and you put plus co here, plus co here in front of these, you get the derivative for cosec x. The only thing that's missing is a minus sign. There's a minus sign that you don't get. So if you put a minus sign here and then put co in front of sec, cosec, so cosec x, and put a co in front of tan, that's cotangent cot x. Yeah, so they're sort of linked in a way, except for the minus sign. Then we've got y equals cot x, and that will give you, and again it's very similar. Have a look at tan here, put a co in front of it, you get cot. Now what's going to happen here, you put a co in front of that, you're going to get cosec squared, and just like the other one we need to put a minus sign in, so this is minus cosec squared. So in a way it's linked, aren't they? Tan and cot are linked in that they look very similar, except we've got a minus sign and a co here and a co there, and the same with sec and cosec. They're linked, but the only difference is this extra minus sign with the one that's got all the co's in. So that's maybe one way to help you work it out. There are some other ones that are given in the formula book as well, so let's put them over here, and these are to do with the arc functions, basically like sine inverse, cos inverse, tan inverse. So if we have arc sine and that differentiated, dy dx, need a bit more space here, is going to give you 1 over root 1 minus x squared. Y equals arc cos x, then dy dx, these are all very similar, equals negative 1 over 1 minus x squared. So similar to the last one, but we have this minus sign. And last one, arctan x, that differentiated, so dy dx, that one doesn't have a square root, it's just 1 over 1 plus x squared. And I think later on you do need to be able to derive these, but we'll go through those when we get to them. So the ones up here in black, we need to know. All the ones in blue, these are all in the formula booklet. You don't need to memorize them, but we do need to know how to use them. Now we know that if y is tan x, it becomes sec squared x when it's differentiated. That was one of the ones that we had at the start, but what we're going to do is we're going to prove it. The purpose of this question is proving that that's the case. So the way to tackle this is to actually write tan x as sine x over cos x, then use the quotient rule to differentiate this. So u is sine x, v is cos x, so that means that du dx is cos x and dv dx is going to be minus sine x. So using that, we're going to use the quotient rule. So we will get dy dx, remember it starts at the bottom is v, so it's going to be cos x v times by du dx cos x minus, and then we start with the u, sine x, and that needs to be times by negative sine x dv dx all over v squared, so it's going to be cos squared x. Right, so what do we have at the top here? We basically have cos squared x plus sine squared x over cos squared x. Now what's sine squared plus cos squared? Well, that's just 1. So 1 over cos squared. And 1 over cos squared, what's that? 1 over cos squared is sec squared. So that's a proof to show that actually tan is sec squared. So we're not just writing down what we get in the formula book, but actually applying what we know about differentiation to prove it. Now I've got this written down here, and actually this carries on from what we did when we differentiate sine and cos. Do you remember if we had not just like tan x or sine x, but what if it was sine 5x, sine 6x? Well, with all the trig functions, if your function is y equals a trig of something x, then that something x stays here, but the something, the k, appears here. Yeah, so if I was differentiating, for example, y equals tan 7x, then dy dx would be 7 sec squared 7x, and this applies to all of the trig functions. I've not put k's in all of them because they're given in the exam book, in the formula booklet without the k's. But if you just remember that this sort of rule about trig of something x, how it can be applied, and you remember that, then basically you've got all those rules. And I think actually we apply them here. So let's have a look at A. So we've got y equals x tan x. We have a product, and with that product, u equals x, v equals tan 2x. I'm not sure why I wrote down tan x, so let's put the 2 in because it does say tan 2x in the question. So du dx, or u dash, is 1, and dv dx, that's going to be 2 sec squared 2x. So can you see this bit here, the 2 is like the k. Yeah, I should do that k a bit better. So it's like the k here. Yeah, and that's how we would apply it. 2 sec squared 2x. Right, so now we can just stick everything in the product rule. Now, because there's a plus in between the two parts of the product rule, it doesn't matter the order you do it in, but I'm going to start with v. So I've got v times sorry, I'm going to start with u times dv dx. So that's 2x sec squared 2x. So that's these two done. So now I'm going to do these two. So plus v times du dx, well, that's just tan 2x times 1. Okay, so that's done. That will be our final answer here. Okay, let's have a look at the second one. B, y equals tan to the 4 x. So whenever you get powers of trig, always start by writing it like this: tan x in brackets to the power 4. So here we're using the chain rule, so I could write u equals tan x and so on to work out what the solution is. But it's easier to use the rule that you differentiate the outside like that, the inside of the bracket doesn't change, and then you multiply by the inside of the bracket differentiated, and tan differentiated is sec squared. So we could leave our answer like that if we like, or we could say, right, let's write the power and put the power here instead. It's the same thing, it doesn't make any difference. So that'll be our final answer for B. Let's get the highlighter pen rather than a pen. Let's just highlight that for B. Oh, and that's it. I thought there was a part C. So that's B done. Right, show. That means that we don't just say, right, in the formula book it says it's that. We actually need to work it out. And whenever we have questions like this and we need to prove what trig functions are differentiated, we normally want to write things in terms of sine and cos. Right, in terms of sine and cos, because we've proved those from first principles, haven't we? Well, at least we did sine. I think cos is in the book. That's one that you need to prove. But if you've proved those from first principles, you know what they are. So that's always going to be our first step. Can I write it in terms of sine and cos? And yes, we can. Y equals cosec x, and cosec is the same as 1 over sine x. So here we have a quotient with u equal to 1 and v equal to sine x. So that means that du dx is 0 and dv dx is cos x. So if we plug all of those into the quotient rule, we get dy dx equals, so we start with v sine x times by du dx 0 minus u times by dv dx, which is cos x, and that's all going to be over v squared, so sine squared x. So if we simplify that, we'll get cos x over sine squared x. Now almost there. This can be written as cos over sine times by 1 over sine. If you multiply that, you get that. Now the reason why we've written it like that is because now let's have a look. I think I've missed a minus sign out. Yes, I should have a minus here because I have a minus here, which means I'm going to have a minus here. Sorry about that. Should have put that minus sign in like that. Shouldn't have missed that out. So yes, the reason we did it like that is because cos over sine is cot x and 1 over sine is cosec x. So we've actually finished and we've got what's required, which is negative cosec x if you just change the order around, cot x. So we've proved it as required. And you could do the same with proving sec x or cot x, similar proofs. Be prepared that you may be asked to do that in the exam. Right, so here we have y equals cosec 2x over x squared. So we have a quotient, u is cosec 2x, and v equals x squared. So du dx, this is that funny one that's got 2 bits to it. This is going to become minus 2 cosec 2x cot 2x. So both of those bits appear when you do du dx in this one, and then dv dx, that's just going to be 2x. So putting that into the quotient rule, we're going to get the bottom, so dy dx is going to be the bottom times by the top. So let's put minus 2 like that, cosec 2x cot 2x minus, and then u times by dv dx, so that's going to be 2x cosec 2x all over the bottom squared, which is going to be x squared squared, which is x to the power 4. Now we can leave it like that, but I do notice that actually there's a 2x and a cosec 2x as a common factor. Now we'll probably only do this bit if I need to find out where dy dx is 0 x to the power 4, and it looks like I'm going to be able to cancel out a power in a moment. We'll do that in a moment. So this is going to be negative cot 2x minus 1, like this, in brackets, and actually that x will cancel down and this will become x to the power 3. Be careful, don't cancel down the x here. You can't cancel down this bit. Yeah, that's not something you're actually multiplying by, but you can cancel it down from this bit here. Yeah, so you could leave your final answer like that. You don't have to factorize it unless the question asks you to. Part B in black. Part B, we have y equals sec cubed x. So remember, the first thing we want to do is to write it as y equals sec x cubed, like that, so that we can use the chain rule. And the chain rule says that we are going to differentiate the outside, so it becomes this. Remember, the inside bracket of the bracket doesn't change. And then we want to multiply by the inside differentiated, and the inside differentiated is going to be sec x tan x, so times by sec x tan x. And yeah, that can actually be simplified because we've got a sec squared x there times by another sec, that makes sec cubed, so 3 sec cubed x tan x. And there we go, we can leave it like that in that form. So there's our answer for part B. There's our answer for part A. Now another show that question. So this is not just saying, right, okay, let's just look this up in the formula book. This is like proving it from scratch. Remember what I said about, can we write it in terms of sine and cos and use that to help us? Right, so show the derivative of arc sine x is that, right? So let's say y equals arc sine x, okay, which is a bit like sine inverse. Now, if I do sine to both sides, so I find the sine of both sides, because I really want to get rid of that arc sine, which is like sine inverse, then I'll end up with sine y, so I'm doing the sine of both sides, equals x. because basically the arc sine and sine cancel out. Now this is one of those things where it's not y equals something, it's actually x equals something, x equals sine y. So I'm not going to be able to find directly dy dx, but I can find dx dy. It's not dx dx, dx dy, and dx dy is going to be cos y. And then if I want dy dx, let's carry on up here, dy dx, that's going to be the reciprocal of that, so that's going to be 1 over cos y. Then the next bit is where we use the identity sine squared, let's call it sine squared y plus cos squared y is 1. Now I can take sine squared away from both sides, so I've got cos squared y equals 1 minus sine squared y. And then if I do the square root of both sides, then I've got cos y equals the square root of 1 minus sine squared y. Like this. Now the reason I'm doing that is because here I've got sine y equals x. So here this is sine y squared. So this is the same as x squared because of what we said and what we got over here. So let's write the steps down. So cos y is the same as 1 over the square root of 1 minus sine squared y. Yeah, and because sine y equals x, so we have 1 over the square root of 1 minus x squared. And you know, we can also prove arctan and arccos in similar ways. So we've done the proof here, and there's our final answer for that one. Right, you should now be able to do exercise 9F on pages 248 to 249 of the textbook.